much for registering for our webinar today, and apologies again for the delay there. We've had a really big uptake for this session, so we're looking forward to hearing your thoughts, questions and feedback. So my name's Joanne, I'm part of the marketing team for RFD Europe, and I'm here with my colleague Alexandra, who is going to be presenting to you today.
Hello everyone.
Alex is one of our reservoir engineers, and she's got great knowledge and enthusiasm in the field of history matching and uncertainty after focusing on this subject for her PhD a few years ago. So I'll shortly hand over to Alex, who will present a few slides to you, and then we'll move on to a live demonstration, and at the end we'll have some time for questions. If you would like to ask any questions throughout the session, you can put these into the questions panel, which is just on the control panel on the side of your screen, and we'll answer as many of those as we can at the end. And the webinar is being recorded, so we will share with you the recording along with all of the questions and answers later on as well. So just before I hand over to Alex, you may have seen recent communication about our latest software update, which was released in October. So I've attached the full presentation for you to access in the handout section of the control panel, but I just wanted to highlight a couple of updates to you from tNavigator 19.3. So one of the big visual changes that we have introduced is that users now have the option of a new interface theme in tNavigator, which is the dark background with the white text. So if you'd like to try this out, you can easily switch between the new theme and the original white theme from the main window of tNavigator at any time. And the second update to highlight is the progress in our GPU capabilities. So as you know, tNavigator users have been able to run calculations using CPU and GPU hybrid option for a couple of years, and now we've introduced the ability to run Blackwell models fully on GPU. So this function allows you to tune the way that you utilize GPU by enabling GPU mode through the following values on the screen here. So no matter what kind of model you have, you can choose the hardware setup that works best. So if you'd like any more information on 19.3 updates, as I said, you can download that updates presentation and of course contact us with any questions that you might have. So now I'm going to hand you over to Alexandra. Hopefully our presentation is going to work and it'll be plain sailing from here. So please enjoy the presentation and ask lots of questions at the end. Thank you very much.
Thank you, Joanne, for a great introduction. I quite like that we have lots of new things to share with you so often. And as we mentioned before, we're going to look for your questions and your feedback during the session or even afterwards, so we can then customize our next webinars for you, as well as see what is interesting and how do you like what we show in you. So today we're going to talk about MultiObjective optimization, and particularly we're going to focus on a specific example where we use it for an assisted history matching. And of course, we're going to do it in tNavigator. So we're going to go through several questions today. First question, we're going to look at why is it useful to use multi-objective optimization. Next, we're going to talk about what is it happening, what are we doing with the multi-objective optimization. Next one, we're going to talk about how. I'll show you how to set up the multi-objective optimization. We see what we can do with the results and how we can analyze them and how we can compare and get a bit more of an insight about our models and about our results. And finally, we're going to talk about so what. That's my favorite question. I think it's very important to know what is the benefit of what we do, what is the purpose of it, and what is the point. And to start with, we're going to go from the petroleum industry into our real world, because most of the real world search and optimization problems naturally involve multi-objective. So therefore, instead of just the one single best solution, we're going to look for several optimum solutions. And all of the solutions are some kind of set-off, some kind of trade-off, or a set of trade-off solutions where no solution is better than the others. To make it a little bit more descriptive, let's have a look at the real-world example. So let's see, we are looking to buy a car, and we're looking for a car with a minimum cost. Don't have much budget, set times. So if I just put this in Google, Let's have a look what I'm going to get. So that's pretty much what I got with this result. Find the car was the minimum cost. It matches our criteria, it matches what we are looking for. However, as you can see, it's still very nice. I mean, you don't really want to buy a car like that. So therefore, if we move from single objective into multi-objective and expand our criteria, so now we're looking at find the car with the minimum cost and maximum comfort. As you can imagine, the solutions that we're getting out of there are much nicer, and there's a broader choice, and most likely you're actually going to buy something like that than the first car on the left-hand side. And it's not surprising, because most of this objectives sometimes can be also conflicting, and therefore when we're looking at different concepts, it's probably better and more logical to look at them separately. Because with the multi-objective idea, we're looking at a compromise, or as I said before, at a trade-off between the conflicting objectives. So let's have a look on more examples about it. So how do we approach trade-off concept, and what is a Pareto front? So when we move now from real life into petroleum industry, we can set up a couple of examples to illustrate the point. Let's say that there's two different examples. On the left-hand side, we're looking at the problem where we're trying to minimize our mismatch in two different parameters. One is oil rate, and the other one is water rate. So when we use multi-objective, we get not just one solution, as I said before, but a set of solutions. And all of the solutions are no better than the other ones, and they're so-called optimal solutions. On the right-hand side, you can see quite a similar idea. The position of the points is different, because in this hypothetical example, we are doing, let's say, well optimization, and we're trying to optimize our oil recovery whilst minimizing the cost. So there we can see how the different idea behind our objectives can change the results and how they look. However, we're still using the same approach to analyze the results. And what else I want to highlight on this plot is the difference between the points where we have numbers. So if you have a look in both plots, we have 1 and 2. And then on the other points where we have letters A, B, and C. So again, in this cases, we separate numbers and letters for a reason. So I would like just to highlight that 1 and 2 on both slides are extreme solutions. So if we have a look at the left example with the mismatches, we can see that our extreme solution number 1 will actually give us a better result on our oil rate mismatch, whilst making the water rate mismatch worse. And the same but opposite works for solution number 2. So therefore, in this case, when we improve one solution, we worsen automatically the other solution. And that's similar for the right-hand side plot. For example, if we're getting the most oil from our field, which would be solution number 2 on the right-hand side plot, at the same time, we're increasing the cost whilst we're trying to minimize it. Nonetheless, in these two examples, there are also many other solutions where a trade-off between objective exists. And such solutions are marked with letters here. And in this case, they are better compromise solutions. So every time we're working with this concept, we are aware that by picking one or the other, we're picking still one objective a little bit better than the other one. You can also see that all the solutions are connected with a dotted line. And this line could be called, maybe you've seen that before, a Pareto front. So this line basically combining the solutions together, given the idea where all this trade-off models, where you can all visualize all these trade-off models. What we know about multi-objective optimization is that there's lots of different ways how you can set up your objectives and how you can combine them. There's quite a lot of research happening on what would be the ideal grouping, how many objectives you can use, and this is not an easy question to answer. Therefore, you could find quite a lot of research going on about that and people trying different ideas. However, there are already several studies that demonstrate the superiority of multi-objective optimization. And in this study, they demonstrate that there's an ability to speed up the mismatch convergence and at the same time to obtain the diverse set of solutions. And this is another point that I would like to talk a little bit more. Again, we're going to do a comparison. Now we're going to compare single objective and multi-objective. So I want to now highlight the differences between the solutions. So we can visualize Pareto fronts for both of these options, for single objective and for multi-objective. And as you can see on the left-hand side, all our solutions, which are black dots, are very close to each other. In a way, they're pretty much the same. So what we can say about the solutions, we can say that they're over-refined, or that means that they're pretty much the same. They are variants of the same solution with just a minimum alteration in parameters. However, on the other side, where we're looking at the multi-objective plot, we can see a very different picture. We can see that our solutions are widely spread, and therefore we're also looking at highlighting the two main goals of multi-objective. So the first goal would be to obtain the solutions as close to the Pareto front as possible. So in our case, if we're looking at minimization, then the plot will look very similar to what you see right now. Or if we're going to do maximization solution, then they're going to be just a slightly different, but still all our solutions, the optimal one, close to the Pareto front. And the second objective is to obtain the solutions as diverse as possible. And you can ask a question, why do we care about diverse solutions? Aren't we just looking for one? I really hope that after this webinar, you will start questioning the idea of just having one solution and looking forward towards creating multiple solutions. And hopefully with the examples I'm showing today, you will also see the value of the diverse solutions. I will highlight it with 2 points. So first, I will just show you straight away what we're looking for and what we can get with diverse solutions. And then we will use and we will do the live demonstration so you would be able to compare the results and see yourself what is the actual difference. So here we go. Here's this question, the favorite question, so what? You can see straight away that if we just concentrate on the history part of our plot, there's not especially much difference between our results. And maybe we wouldn't even notice, and we would say that single objective, multi-objective perform pretty similar and does not affect us or our results as such. But this situation changes as soon as we start looking at the forecast. And you can see that our blue lines is our forecast based on single objective models. In our forecast, we have the same number of results for both the single objective and multi-objective, but the range is quite different. So our blue lines are very close to each other, and therefore our forecast results or our forecast interval of our results is very narrow. So there's a quite big probability that with this narrow range, we're going to miss our truth, or we're going to maybe underpredict or overpredict. However, as soon as we start looking at the results from the multi-objective optimization, the range is much wider. So again, by this, we're expanding and we're making our chances to understand and predict better and capture the actual behavior of the reservoir much better. So this is the main reason why we're doing it. And as I said, we're going to have a look at the model and we're going to try and see what's the difference and compare the results. So we're now going to move on into the live demo, and it will consist of three main parts. So first we're going to set up and run the MultiObjective optimization. Then we're going to do the same with a single objective optimization. And as I promised, we're going to compare the predictions from both of those and see ourselves how we can analyze the results and what would be the difference. So from now on, I'm going to close the slides. I'm going to move into the software. So now just looking at the main tNav window, it's in white. And as Joanne said, if you want to change it to black, it's very simple. So you just go here, toggle dark theme, and here you go. So you can work like that. I've heard quite a lot of comments that dark scheme is not just trendy, but it's also much better for energy saving. So that's just point one. And second, it's also better for the eyes, especially when working with quite small objects and later during the day. So when I feel bored, I work in the white one during the day, and then I switch the dark one during the night. So it's up to you which one you want to use. We're going to open the model, and I'm going to use this example to show you one way how we can set up the multi-objective optimization. There are other ways, and if you're interested to see how we can do it differently or how we can include more of geological uncertainty as well, let us know and we will prepare another WebEx for you as well. We'll open in the project. If you're familiar with tNav, there's nothing new here. It's all the same, just loading the model. I'm doing it from my laptop, so it's good for me to have a teeny tiny model so I can do it very quickly. So that's the model, that's how it looks like. What else can we have a look here? We're going to look at our graphs in a minute. And at the same time, we're going to look at the model description as well as how do we define our variables for our multi-objective history map. So here we go. If I just go to definitions, first of all, I can see that my model is small, and that's okay, and we will be able to run a couple of models live and not wait too much. At the same time, you have already a summary over here of all the variables that we're going to use for this case. So it's very easy to define a variable, and then you can always change it if you need to. So currently we're looking at a summary, and we can't modify anything here. However, if you want to work or you're just starting working, then one of the ways to do that would be through the data file of your model. So I'm going to open a data file and show it once again. So just on the top, we're using two steps. So the first one, there's the first part where we actually define our variable, and the name of the variable does not matter. So it's just something for you that you remember what you're actually looking at. And then we're defining our base value, our min value, and our maximum value. So as you can see, we have a list of variables here. Most of them, or like half of them, are related to our real terms that are defined through Cori. The other ones are related to our properties. So we're going to change our permeabilities, both horizontal and vertical. And one more, we're also going to look at our fault transmissibility as well. The second part of the process where we define the variables through the data file in our dynamic model is to actually put the variables in the right place in your file. So I'm just going to scroll down a little bit and show you how it looks like. So here we are, and here's our variables. We have our fault transmissibility, it's just here, so we're using the @ signs, and we put the name of our variables in between. As simple as that. Then we're changing our horizontal and vertical permeabilities. Here we are. And finally, we're looking at our critical water saturation and our exponent in the Cori for two different regions that we have in our model. So as soon as we're happy with our variable setup, we can go at the model, look once again, and think about what is the parameters that we want to use to match. So in this case, I'm going to do a list of the parameters. So I'm going to look at the mismatch for different rates, as well as I'm going to do the mismatch on RFT. So I know that for this model, there are some RFT data for well number 7. So it's important to have trajectories of the well inside the model. So I'm just going to check that trajectories are in. And the next step, I would just need to load the RFT data in the model. To do that, we just need to go to the load well data option, well logs, and find the file with RFT data. So I have it prepared here. There's a little window where we can check that the information that we put in is correct. When we're happy with that, we say OK, OK again. And then we can go to our graphs well section and visualize our log for well number 7. So we have the log in. However, it's good to go through the configuration option and select which log we're going to work with. Because you can use the same approach for PLT as well. Therefore, to distinguish between them, we just need to say that's RFT that we're currently using. So we're saying OK, and after that, we can run the model. So we will get our calculated RFT, and we can also then visualize our results for rates and compare how far away they are from the history. So I can already see that we have 2 RFT logs. So let's just see here, right? Okay. Making it a little bit bigger so we can compare. And if I put one together, that's a very good way to see the mismatch. We can always change the colors, change the lines to make it more customized if you want to. There are quite a few options to do that. And we also can have a look at our rates. So we're looking at several things. We're looking at our oil rate, water rate, and gas rate. I'm just going to add gas rate here and gas history. So that's just to show you that we do have the mismatch in the model. The biggest so far is in gas. And if you're also wondering, this is something that we heard several times from people, how to customize your graphs. When you're looking at your graphs and maybe oil mass rate or water mass rate is not something that you want to see, this is a very simple step now how we can change that. We can just go to our main window. We go into settings, options, models, and just here at the bottom, hide mask graphs. So I'm going to select that, apply, OK. Already done it on my computer, now it's on my laptop, and it's perfect. It's just the way I want it. But back to our problem. So we have mismatch in our rates, as well as we saw that there is a mismatch in RFT. So this is what we're going to try to minimize. We're going to try to minimize that both. If we want to go from here to the history matching, we can now click on the button here, check once again that our variables are in the model the way we want them, and just say create history matching project. We can call it as we want. So I can call it webinar save. And as soon as it's saving, we're going to get several extra options to select from. So if we're all happy with standard settings here, this is for you to see that my mini laptop was just 2 cores, but still able to run a couple of small models, no problem. After we're happy with our settings, we now go into the window where we have the algorithms and we see the full setup of our parameters. And here we have a choice where we can select or deselect our variables if we change our mind, as well as we have a big library of different algorithms. You can see that they are divided into 2 parts. We have the top part with so-called experimental design ones, and the bottom part we're looking at optimization. Most likely we would recommend to do it step by step, starting maybe with your sensitivity runs and then moving into history matching. But in this case, today we're going to be naughty. We're going to skip the part. We're going to go in the particles form straight away because the main focus is to see how do we set up the multi-objective. Okay? I'm going to go and show you that if you want to select the multi-objective straight away, you just need to activate the option and select the set of objectives that you want. However, if there's something customized and it's not in the list that you get here, you can just go and configure your own one. So I'm making it bigger on the screen so you can see that we currently are at the side where we can specify our objective functions. And I'm just going to create 2 of my own custom objective functions. The first one, I'm going to add, and I'm going to do the rates. So it's actually going to put all rates together as one objective. So we have rates, and I'm going to go from top to bottom. And to know that I'm on the right way, I would need to get rid of this red line here and have a blue one saying OK. So that's my way to know that I'm doing the right thing. So first, I'm going to do oil rate for all the wells individually. To do that, I'm selecting all the wells and picking the oil rate on the bottom. Then I'm going to repeat this process for the other terms of this objective. Very similar, just do select all the wells, move into water rate, and finally the same one for gas rate. There are quite a lot of ways how you can do the same operations in here. I'm just showing the one how I prefer it to work, but there's always other options to do so. So we finally get our blue OK sign on the bottom saying this is all fine. We can move on, create a second one. So have a plus button again, and I'm saying RFT. So I know that's going to be my RFT. So here, doing it through all over again. For RFT, we need to change the type here in this graph. So we select RFT. We don't need all the wells because we know it's for the well number 7. So we're selecting our wells, highlighting again RFT, getting our OK at the bottom. So we are good to go. So from here, we just need to come back to the same menu we were a second ago. We still select which algorithm we're going to use. And I would like to highlight that in tNav, we have 2 options to do multi-objective. We can do it in particle swarm optimization, or we can do it with differential evolution. If it's something interesting for you as well to talk more about the algorithms and differences and comparison and studies, let us know so we can do something like that as well. Concurrently, I'm just picking one and carry on. Activating multi-objective, selecting, and now in the list, I have the 2 ones that I just created. Click on one, click on another, configure, here we go. So this is actually done, and I think it's running. Maybe I just do once again to be sure that I clicked all the right buttons. All right, here, this, OK, and OK again. Right, here we go. So we're starting calculating, and I have 2 options now. We can go for a break and come back in 4 hours. Oh, I can see people laughing. Thank you. It's very, very, very nice that you react on my jokes. And the second option is I'm just going to stop it now and bring some of the results that I've done beforehand so we can have a look and work and analyze the results. So I'm stopping this one, closing and opening the other one where I have my results. I actually did several things, so I'm going to show you just a few. So my first experiment was exactly the same one as we just saw and I just set up. So there's a particle swarm with all the same variables here, and I can have a look that this is the same 2 objectives that I wanted. Then I also did something in advance. I did the particle swarm with a single objective. And for this objective, I just select the oil rate mismatch for all the wells. So that's it. I let it run for about 300, 400 runs for each. And with my small models, it didn't take too long. So I was able to just let it run without really controlling or stopping or monitoring. And as well, I wanted to show you what's the difference in the forecast. So I have one forecast prepared and the other one we will do together. So let's have a look at the results first. I'm going to select my particle swarm multi-objective optimizations run to start with. I'm going to look at the graphs. So once again, just checking that it's only one experiment at a time. And you can see that if we're going to switch between different rates, oil rate, water rate, gas rate, our data that are our historical data with black dots are within or covered by range of our solutions. So we're definitely getting quite a few models that are matched for our rates. However, when we do multiple history matching, we have an option to look at our spread of solution. We can have trade-off solutions, and we also look at the Pareto front. So it's quite important to see how many runs you do. So I already have one here, but I'll just quickly run through how exactly I created this cross block. If I go on the top hand side and configure my y-axis here, I'm just clicking on mismatch, and then I can select which one I want. So for y, I can go for all my rates. And then on the bottom, I have the x-axis, and again from a list, I'm selecting mismatches and selecting RFT. So here you can see that there's quite a lot of different solutions, and some of them are far away, and some of them are actually quite close to the 0 values, which are kind of left corner of the plot. And actually that was already the maximized view. So I just did to show you the full spread of solutions and how far some of the solutions are. The shape of the Pareto really depends on the number of simulations, and it's something that you can have a look and define yourself. So for these studies, we did several runs to see and compare how the shape is changing and how the results are changing, and therefore defined the optimal one. So for this case, the optimal was somewhere about 100 or 150 runs, but I actually decided to do a bit more and just to see how it's going to affect on my results. So I did up to 300. And if I have a look at the models here that are quite close to the minimal solutions, we see they're somewhere about 245. So this is something new. So we was running longer. We actually can get smaller values for our objectives, which means that we minimize the mismatch. So now I'm actually going to create the Pareto front by distinguishing the colors of the models that are on the Pareto front and the rest. So I'm going to do it for my MultiObjective front. So I'm selecting all the models and then going through the options, and I'm looking for that one, create Pareto front from selected variants. So click on this, and again choosing which ones do you want to visualize, because you can have more than just 2, but with 2D plots you are restricted to how many you can visualize at the same time. So we have 2, the ones that we wanted, and here we go. So as you can see, just scrolling a little bit closer, we have all our Pareto solutions are in red, and then we have the rest are in grey. And from there, I'm going to do 2 things. I'm going to actually open one of the models and have a look at the results individually. So let's say, taking this model, it's highlighted on the graph, so I can just go and straight away say, open the model. And we will compare how close we are to our historical data for rates and also for RFT. So this is something that we can do quite easily, and at the same time use quite unique graphs to do so. So first I'm comparing the rates. So for example, oil rate to start with. And by moving the time slider of the model, I can see that all the wells here are going to move and change. So everything that is close to green line and within this 2 red lines, which is our tolerance, will mean that we have a good match for our wells. Some points, some wells are not there, especially this well number 7, where we're trying to minimize our RFT mismatch as well. So some of the solutions can be compromised, and it's up to us to decide, are we happy with that or not. However, if we have a look at the numbers, the mismatch at the end is not so critical. It's not especially big. So maybe if we make our tolerance slightly bigger, that would be actually inside the interval. So it's something to think about. And then if we look at the well sections, we already have our both RFTs here. And from the first, it's not easy to notice the difference, which is a good sign. That's exactly what we want. So we were able to do that to match. Now I'm going to go back to the AHM project and show you now how we can work with, or what kind of results we're getting with our other runs. So now I'm going to uncheck this and go to number 4, which was my single objective run. So I'm marking this group and going back to the graphs. And if I just add the history as well for your reference, you can see that our oil rate, water rate, gas rate actually covered very nicely as well. And there's not that much difference in the visual and our results at that point. So therefore, when you just do it for history matching, you might not even notice the difference. The difference will come later on looking at the forecast. So from here, what I'm going to do, I'm going to show you 2 things. So I'm going to now move into the forecast. And with the forecast, I'm going to show you how the forecast looks for multi-objective. And then also create the forecast for single objective. So I'll probably start with creating the forecast for single objective, and then we'll do the comparison. With forecast for single objective, I'm going to pick the top models with the smallest mismatch. When I look at the Pareto front before, you saw that we had this models already defined, and therefore from this models we can do the forecast. And on the plot there was about 7 or 8 models to do so, and we're going to pick the same number for single objective. So I'm going to go to my the result tables where I can visualize all my results, not as graphs but as values. And I'm going to pick my mismatch, which was just the oil rate for the single objective. So I'm going to bring it and just put somewhere on the top. Sometimes doing it like that when the mouse is not picking it up. Just a couple of more clicks. Okay. Okay. It doesn't really matter where it is, it's just for my convenience, to be honest, that I know where it is. So I'm looking at the oil rate mismatch, and I'm going to sort the models to see the smallest mismatch on the top. So therefore, we have now this set of models, and just because I want to have the same number of single objective models for the forecast as for multi-objective, I'm going to pick the top 8. So 1, 2, 3, 4, 5, 6, 7, 8. So from here, I can just say, create my forecast. When I create the forecast again, I can see what the values are picked. I'm going to say, OK. It's all configuring, creating, and start running. We can always go in calculations, scroll to the very bottom, and have a look that the calculations are running. So whilst it's running, I'm going to show you quickly how we can visualize the forecast result for the multi-objective. And as you can imagine, it was done exactly the same. So I just picked the models that I want to use and say create forecast. When you do it for the first time, you have several options how you can specify or how you can set up the forecast. So from here, we have an option where you just continue the same schedule, the same parameters as they are, or you can do a user schedule, so you can upload your own user schedule, Or another, which is quite cool, that you can do the user schedule with variables. So we actually do in the forecast optimization where we can do where our variables could be, for example, well controls or well locations. So this is something very interesting that could be done as well. So in my case, I just picked the first option because that was what we were looking at. We wanted just to compare a simple, if we run a forecast from here, what will happen. So my laptop is going through already 2, so that's going all right. Going back to the results, and you can see that the forecast models are appearing right under the ones that we used as the history to start with. I'm going to go to the graphs and I'm going to start setting up the forecast run to compare and to show. So let's say we're looking at oil totals, and every time we're going to get a new forecast from SingleObjective, it's just going to appear here. So far looks good. We see the spread of all our historical ones. And I can also now go and find the models that were my forecast from MultiObjective. So that was my experiment number 3. So you can see just a few, 8 models. So I'm going to check them as well. Mark this group checked. Okay. And what we see so far is something very similar to what I was trying to show you on the slides before, trying to answer the question, so what? So what? So here we are. We're looking at the forecast. We saw that the history was matched pretty well. We saw that for MultiObjective because we had RFT as well. We were matching it nicely. And at the same time, we could see there's a little mismatch for some wells. So we see this trade-off option or the trade-off effect here. And then finally, we're looking at the different spreads. So in yellow, we have our spread of MultiObjective. I'm just going to go closer. So we're looking at the yellow so far. And if we look at the numbers, so this is 136, and this is 145. So we're looking at around like 9,000 cubic, what's that, centimeters? Oh God, I'm just making up words. Yeah, just checking that the units are correct. So it's about, well, I don't know, 57 barrels. I'm just doing a quick conversion in my head, which is quite noticeable when you work with something like that. So it's a big range. It might not look big from afar, right? But when we get closer, it looks bigger. Whilst we're looking at this, we're actually getting our SingleObjective. So they're in the different color, and they're somewhere in the bottom. So there's the brownish color. We have 2 models. But even already very close, we can see that we can't really see the difference between 2. So we need to get even closer and closer and closer to actually see the difference. So we get exactly this effect of the models being too close to each other and just slightly alteration. There's the third one appeared and just the same. So a difference between them, you can see, is pretty much not noticeable. So on this note, we can continue running and visualizing more models come in here, but we also can start looking at the questions and answering them as well. And probably by the end, we will have exactly all 8 models, and I'm sure they're just going to be all here to prove the point. We'll check as well. Okay. So Joanne, what would you like about the questions?
Let me look. We do have a couple here.
What
if we introduce rates and RFT match in the same objective function?
Okay. So by this, does it mean that we put in, so we're not using the MultiObjective then? Because if we introduce rates and RFT match, that's exactly what I did, but I separated them. However, I know, I see what you mean. Okay, it's like to do the comparison where I put all together and compare it to that. That's a good one. I'm going to check it. I'm going to put it to run tonight. So we're going to see results tomorrow morning. and we can share the results with you just to let you know on is there a difference or not. Because I did just a quick one, yeah, to check. Thank you for more ideas and for the smiley face as well.
Another question here. How many objective functions can you use?
Oh, that's another good one. Well, to be honest, I saw that mainly 2 or 3 are used together, and one of the reasons I think it's because when you try to visualize and then analyze the results, we are, well, not limited, but it's easier to work in 2D dimensions or like 3D plots. We can do more, but it gets trickier when you have more dimensions just by that. I actually had a look just out of interest to see when I was setting up my my test case yesterday how many people normally put, and I saw that 8 was also an option. However, I didn't actually read the paper where they were doing 8 objectives. I just put something that I'm going to read because it was really intriguing. Mainly myself and my colleagues at the university did 2 or 3, and then also what they were doing is grouping. So if you work with more, then you try to group them together, and that's how you can minimize the number, yet account for lots of different things together.
Okay, question here, thank you. What is another combination of parameters to be used as objective function, other than the ones you used today?
Oh, you can be as creative as you want, and if it doesn't work, don't blame me. But what I saw people normally doing, because everyone is trying to match similar things for mismatches, I saw people combining or doing multi-objectives in separating BHP for different wells and rates. So instead of RFT, that's another way of looking at pressure. Some people used GOR instead of rates, or maybe water cut instead of rates, or combining with rates, for example, oil rate and water cut like that. So that's something I saw, and I think it's quite possible to try. But if we look into multi-objective optimization, when we actually optimize, and then you have option of put in your NPV, you put in your cost, put in your rate as well as separate objectives here, depending again on the study, could be more than just what I showed for sure.
Okay, one more question for me. Is it more efficient to match rates and pressures by splitting them into 2 objective functions, or the benefit of multi-objective functions is mainly in the forecasting mode?
All right, okay, I see. Okay, so I didn't do that one for sure. To say that in this case, what I did, I have an example to show you that what's the advantage. But when I looked at the researchers, I was saying that people looked at the rate of the or speed of the convergence, and they were saying because we split in this and not putting all together, we can converge faster. So when I'm running now the little model, I could just let it go for 400 runs and so on, and even more. But if the number of runs is actually a restriction, then of course you're going to look at something that you can converge faster. And that was one of the aspects I saw at other papers.
Okay. One other question? Or just check
I'll just see. Well, we can do one more question, and there's one more model to calculate.
Can you combine WCUT, IFT, GOR, rate, etc., all in a single custom objective function?
Okay. So we can do it for sure. The question is, how good is that? Because we also need to think about how they're gonna. So you remember I mentioned something about conflicting objectives. So there is a risk when we start to mixing conflicting objectives together. Because if we mix something conflicting, then it's very tricky to actually get anything meaningful out of it. Because when we separate the conflicting objectives, then we have an option to maybe by improving one, we also finding the balance to how much we can improve this one without spoiling the other one too much. But if you put them all together, then you don't have this option, because if they are conflicting, you just either minimizing all, maximizing all, but probably never getting something optimal at all.
Okay, we do have a couple more questions. Maybe we can come back to them just before we finish.
Sure. So I have now 8 models, and as you can see from far away from the distance, it doesn't seem that the graph changed much. But again, gonna do my close look. So here we go. Still in yellow, this is my multi-objective, and then gonna zoom on the single until we start seeing the difference. I'm pretty determined to see all 8, but that takes a lot. Maybe there's a limit to zoom. Oh, I just discovered the limit to zoom. I can't zoom any more than that. But that's even proving the point that they're just all together. And here we are, the main difference between multi and single. Okay?
Okay, cool. Thank you. A couple more questions. What is the optimization algorithm? I'm sorry. What optimization algorithm do you recommend based on the model size?
I'm not sure that this is on the model size, to be honest. I mean, we're talking now about multi-objective, so therefore we're talking now about 2 algorithms to start with, particle swarm and differential evolution. Don't think it's about the model size. I think it's more about the number of parameters and how complex are the models. Because with the model size, it's something else that you can deal with. But on the other hand, if we expand in more than multi-objectives, then sometimes people use proxy for bigger models as an option. And yeah, I think so. I think that it's not maybe about the size as such in this case.
Okay, one more question. There is only one reservoir, however. How do you select the model that best matches the performance of the actual reservoir?
So I'm just processing it again. There's only one reservoir. So how would you select the model that best matches the performance of the actual reservoir? Okay, so I kind of think it's more about, again, the deterministic and probabilistic discussion. That's how I see it. For example, if we only have one reservoir, right, it's very hard to just be sure that with one model we're going to definitely describe the performance of the actual reservoir, even if we match them well. We know lots of different examples that we can match pretty much anything, and therefore with having only one or a few models, we are still in risk that we're not capturing all their uncertainties, because there are uncertainties that we know and there are always uncertainties that we don't know. So therefore, I'm not sure how to say if we can only, well, I'm on the probabilistic side for sure, therefore I believe that we always need to consider multiple models as matched models for the forecast of our reservoir instead of 1 or 2 or 3. So if we can do more, that's good.
Okay, I think we should probably finish up there. There is a few questions that we haven't had a chance to answer, but what we'll do is, as I said at the beginning, Alex will answer all the questions, and we will send that out to you along with the recording of the webinar. And of course, if you do have any follow-up questions, Alexander is happy to answer them as well. So thank you so much for joining us today. There will be a short survey, I think, when you just go to close off your screen. So if you've got any feedback for us, please do pop it in there, and then we'll want to hear your thoughts. So thank you very much, everyone.
Thank you very much.
We'll see you again next time.
Bye.